Welcome back to the Unikaksha. So in the last session, based on the same topic, we have discussed about linear regression and logistic regression. So today is the time to explore more such examples, like which machine learning algorithm to use at what kind of data. So today we are going to start up with something called as the KNN. Now, how KNN works? KNN basically stands for the K-nearest neighbor. So suppose say you have been provided with two categories, like as you can see on a screen. One is the point with the green color and another one is the points with the orange color. So these are two established categories. That means this is a kind of a data where categories provided. So this is supervised machine learning algorithm. In this case, there comes a new point which is denoted by this blue circle, and you have to identify that whether it should belong to the category A or it should belong to category B. Now, how to identify this? So we'll try to find out a distance of this blue point from all the points that are given in this near vicinity. So I just hope you know how to find out a distance. You may use the Euclidean distance formula, you may use Manhattan distance formula, you may use the square distance formula. So one can use, any distance formula that one wants to use and can calculate a distance. After calculating the distance, you have to decide the value of k. So for example, if I'm deciding the value of k is equal to 1, then I'll try to find out the one nearest neighbor for this. Suppose that comes out to be this point. Now, the class of this point is green. That's why my particular observation will also be classified as a green. If I consider the value of k is equal to 2, then in that case, I have to look for two nearest neighbors. So for example, this is first nearest neighbor, this is another one. And in this case, we can find out that both the neighbors are green in color. So as per the rule of maximum vote, this answer will also be predicted as green only. If I consider the value of k is equal to 3, suppose this comes out to be the nearest, this comes out to be the second nearest, and this comes out to be the third nearest, then too, in the three neighbors, you have two neighbors which are suggesting for the green, and one neighbor is suggesting for the orange. So by the concept of maximum vote, again, you can say that this should be classified by the green color only. So this is how KNN works, wherein you simply have to identify the distance. In the observations, you have to select the k nearest observations. You have to look into their actual classes and you have to take the maximum vote before making your decision. So how the data of k nearest neighbor would look like. So let me just show you one very simple data related to k nearest neighbor. So as you can look into this particular data, this data is a data about the mining industry. So in mining industry, before starting the mining, if we come to know that whether there actually exists some kind of mine, such as gold or something, or is it simply a rock? So if we come to know this beforehand, it saves a lot of cost, it saves a lot of human efforts as well. So here is the data which is collected from the sonar frequencies. And on the past data or the past researches that have been made, and they have identified a final class that whether the finding was a rock or whether it was a mine. So you're having this as a dependent variable, wherein the values either R, which stands for the rock, or either M, which stands for the mine. So I think I have this observations of M category at the end, like you can see here. And if you just see, these are just the 60 frequencies value that has been given. So based on those frequency values, you have to create a kind of model which will help you to understand in future that if all those 60 frequencies are given to you, then are you able to predict that whether it is rock or whether it is mine? Because if you can predict this beforehand, then it will be very, very, very grateful because there is no need of unnecessarily digging up the mines. So I just hope you got the problem statement. So in order to solve this, suppose there comes a new observation. So you're going to calculate its distance from all the observations that are listed over here. Then you'll find out the value of k. That is nothing but how many nearest neighbor you're looking for. Once you fix that value, then suppose say this first, fourth, and seventh observation is the nearest observation. Then we'll try to find out their actual value. So actual value is r. That is nothing but rock all the three times. And so you'll see that by the concept of maximum vote, your prediction is also going to be rock. So this is basically how the KNN is implemented. Let's check one more algorithm, which is called as decision tree. Decision tree is again a very simplest algorithm where it uses the past data in order to predict what will happen in future. The main intention of the decision tree is whenever you're provided with a heterogeneous data, you have to divide that data in such a way that you will start getting the homogeneous subsets out of it. So for example, if you want to disperse a loan to the customer, so the first thing that you're going to ask is what's the income? That's going to be the first and very important question. If the income is less than a certain range, then you'll say that obviously you're not going to provide the loan. If the income is greater than a certain range, then you're going to ask the next question in order to filter out the furthermore data. So you'll ask that whether you're having the required documents and so on, and so on. You'll start scrutinizing on that data. So you'll be having the huge heterogeneous data. You're asking the questions and you're filtering out that data. Once you filter out the data, you get a subset of information which could be homogeneous. If it is homogeneous, no issues. But if it is heterogeneous, then you again have to split that data. You have to continuously do this process till you get the small subsets of the homogeneous data elements. Once you get all the homogeneous data elements subset, there your decision making stops. So where I can use the decision tree algorithm. So as you have seen in the KNN is beneficial when you have a lot of numerical variables because you have to identify the distance, which can be calculated only in a numerical type of data. But whenever you're performing decision tree, as you're creating a subset, which will be a very easier act if you're having the categorical type of data. So when you have a lot of categorical independent variables in your data set, go for a decision tree because it will help you to generate more and more interpretable results as compared to that of any other mechanism. So in this today's tutorial, we have seen two very important mechanisms and when to use those mechanisms in which situations. We are going to have more such discussion on more such models in our upcoming sessions. So till the time, stay tuned.